Hello students, welcome to Future Doctor NEET Academy. Today I am going to solve 7 problems in solid state lesson. Now let us see the first question in the chapter. See the first one. The FCC crystal contains how many atoms in each unit cell? That's a question. So FCC means the atoms occupying in corner as well as face center. Okay, first you should know simple cubic means atoms are present only in corner. BCC means atoms are present in corner as well as center of the cube. In case of FCC crystal, the atoms are occupying in face centered as well as corner. Okay, so if you know this, you can use to find out answer for this question. Understood? So here in face centered, the atoms are present in what? Face centered cubic atoms are present in corner as well as what? Center of the face, or center of the face. Are you following? Center of the face. Okay. So corner means each corner atom shared by 8 units cell. No. So we have 8 corners is present. So this is a calculation. 8 into 1 by 8 plus center of the face means each face centered atom shared by 2 unit cell. Understood? Each face centered atom shared by 2 unit cell. There are 6 faces is present. No. So each face centered atom shared by 2 unit cells. So this is a calculation. So if you simplify, we can get answer. 1 plus that 3, we get what? 4. Simple one. So answer is what? 4 is the answer. Are you following? See the next one. A compound is formed by cation C and anion A. Anions forms hexagonal. See, anion means we can write. So first you write cation, anion. Understood? Anions form hexagonal close bracket. HCP means what kind of voids are present means hexagonal, CCP. These are all having octagonal voids are present. That. Understood? Here we have octagonal voids. Understood? OV I put in cation. See the cation occupies 75% of octagonal voids. Here also octagonal voids. Understood? Octagonal voids is present. Okay. So that octagonal voids means what's the formula? That number of atoms, number of voids. The number of octagonal voids is that what is that? Number of octagonal voids is what we consider n. This is also n. Okay. Okay. But in cation occupies 75% of octagonal voids. Okay. So 75% is what? We can write 3 by 4. Are you following? 3 by 4. Okay. 3 by 4 into n. Understood? Okay. Now n and get cancel. We can write what? Simply 3 here. 4 if you cross multiplication we get 4 here. So what? So formula will be what? C3A4. C3A4 means so D is the correct answer. Are you following? Understood? Simple one. Okay. So you must know octagonal voids means only n. Number of octagonal voids. Tetrahedral voids means here we get what? 2n. 75% means I put what? Only 3 by 4. So this is all you must know. Okay. Right. Next one. A metal crystallizes with a face centered cubic lattices. The edge of the unit cell is 408 picometer. The diameter of the metal atom is what? They are asking. Okay. Okay. So we have each and every kinds of unit cell. We have formula for radius formula will be there. No. Okay. For in case of FCC, what's the radius formula? Radius is equal to what? A by 2 root 2. This is a formula for radius of atoms in FCC. Okay. So edge length is given. No. Edge length is what? A is called what? Edge length. So we can just substitute. We have what? So 408. Understood? By 2 root 2. Understood? So that here simply you can cancel. We will be getting what? We will be getting 204 by root 2. So root 2 means 204 by 1.414. Understood? Okay. So it will be simply we can write. Okay. Now if you suppose 204 by 1.44 means it will be simply we'll be getting like this 144.2 or something. Okay. So this is radius only. No. Okay. But they're asking what? Diameter. They're asking diameter means it will be twice. No. So 144 into 2 means approximately it will be nearer to what? 288 picometer. Are you following? Radius only usually they ask, but in this sum they asked what? Diameter. Okay. Okay. Twice the radius is called diameter. Okay. Right. Next one. The ionic radii of A plus B minus ions are given. Okay. Ionic radius is given. They're asking to find out the coordination number. Okay. Of AB. So that what's the formula? Radius ratio formula is there. No. Radius ratio means radius of cation. No. Radius of cation by radius of anion. So you just divide like this. We get what? Radius of cation. So what? 0.98 into 10 power minus 10 by what? 1.81 into 10 power. So minus 10. It will be cancel. No. So we'll be getting what? 0.98 by 1.81. It will be approximately 0.5 something. No. Okay. It will be nearly 0.5. Okay. Nearly it will be cancelled. No. So 0.5 something. Okay. Right. But the question is what? What's the question? The coordination number of each ion in AB. Okay. So here it's called it's octagonal. Okay. Suppose here we have the debate based upon 0.12, 0.2, 0.22, 0.4. Okay. 0.42, 0.6 like this. No. 0.72, 1. So we have based on this ratio we can predict what kind of the atoms is, what kind of the molecules are there, what kind of shape we can able to predict. Okay, so it is called, it is octahedral. Okay, so simply you can say answer is what. So here we can predict the C is the correct one. Understood? Right. Okay, so we have values will be the radius ratio value will be there. From the radius ratio value we can able to predict. Understood? Right. Next one, that this also based on octahedral tetrahedral based on some. Here, see that the structure of mixed oxide is cubic close packed CCP. The cubic unit cell of mixed oxide is composed of oxide ion. 1/4 of the tetrahedroids are occupied by divalent metal. So this is called A. I consider it is a A and B. Okay, we consider two element. Okay, 1/4 of the tetrahedroids. It's a tetrahedroids. Tetrahedroids means I put what? Simply TV. Okay, A is what? Tetrahedroids. Okay. 1/4. So 1/4 means this is tetrahedroids means what? What's the formula? 2n. No. So 1/4 means what? 1/4 into that. Understood? Are you following? 1/4 of tetrahedroids of divalent. Okay. Next one. Octahedroids are occupied by monovalent. Monovalent means here B is a monovalent. So this is called octahedroids. So simply write O octahedroids. So octahedroids means what? Only put n. Okay, that's all. Then you cancel this one. We get what? 1/2. N get cancelled. So we get 1/2. Here we have only one in the one is there. So you cross multiplication. So if you cross multiplication means what? We will be getting A will be 1, B will be 2. Understood? Right. Are you following? Right. Then oxide. Formula of the oxide is given. No, oxide you put just O2 at last. Okay. So A1, B, okay, B2, A1, B2, O2. O2 you put at last. So answer is what? D is the correct one. Understood? Are you following? A1, B2, oxide. No, oxide also you should add. Say AB2, O2. That's the answer for this. Are you following? Next one. A solid compound XY has NaCl structure. If the radius of cation is 100 picometer, the radius of anion will be what? They're asking. Okay. Right. As usual, that I told you in formula, no? Radius of cation by radius of anion. Understood? Which is okay. Right. Okay. So here NaCl. Okay. Now see the sixth question. So the radius ratio formula, radius of cation by radius of anion. Okay. So is equal to one value is there. Okay. So that value is not given. But how to find it means NaCl structure is it's octahedral structure. So its values are in between 0.4 to 0.7. No, okay. So 0.4 to 0.7. So here we consider the 0.4. Okay, right. So we consider it's called 0.4. Okay, or 4.1 I consider. Understood? So 0.4 to 0.7. It's octahedral structure. So I put 0.41. Okay. So here if the radius of cation is what? So 100 is given. So 100 following the radius of anion. Understood? Is equal to what? 0.41. Okay, so rearrange. Therefore, radius of anion will be what? 100 by 0.41. Okay, so approximately this will be equal to what? Here, that. So approximately the C will be the answer. Okay, so when you divide, so okay, you must know here each and every one we have values will be there. So what kind of structure this compounds having? Then only we can able to find out. Okay, right. So it will be 241.5 picometer. Okay, next one. The appearance of color is in solid alkali metal halides is generally due to what? It's a question. Okay, defects we studied. No, it's a stoichiometric defect, non-stoichiometric defect. In non-stoichiometric defect, metal excess defect, metal deficiency defect. In metal excess defect, so the defect due to the excess cation. Okay, suppose here in the appearance of color in solid alkali metal halide is generally due to what? That's a question. Okay. So it is due to suppose you take sodium chloride in a vessel, that sodium chloride means Na plus Cl minus, Na plus Cl minus. Okay, here it will be Cl minus, Na plus Cl minus, Na plus. Okay, suppose here in this crystal, if you pass sodium vapors, whenever sodium vapors, if you pass means what happen? When sodium vapors are passed, when it goes inside, it will be what? Na plus and one electron, isn't it? Are you following? It has one valence electron, no? Whenever it goes inside, so the Cl minus ion automatically it moves to the surface. Whenever Na plus goes inside, Cl minus moves to the surface. So here vacancies are created. No, so there is a vacancy will be created. That vacancy is compensated by who is coming that place. The electrons are coming to the place. So here electrons are moving. Whenever electrons are moving means we are getting some color. So color due to the anion vacancy are compensated by the electron. Then only we can say it's called Farbesson center. Nothing but it's called F center. Okay. So the sodium chloride is yellow in color due to the reason they're asking. The reason is only one reason, what? F center. F center means is a color center. Okay, or far person center. Okay, right. So these are the 7 questions in this solid state lessons. Okay, so simple, density of the unit cell, atom per unit cell for FCC, BCC, simple cubic. Okay, then this and all, if you know, means this is the this is a theoretical part. Okay, so defects in the crystal, we have various kinds of defects. No, so this and all, if you know, means you can able to get at least, they will ask at least 2 questions, maybe one from theory or one from problem oriented questions. Okay, so we'll be getting the very easy chapter. Okay, all the example study, that is types of solid, we have types of crystal solid examples are there. This and all, if you cover means you can get easy to get marks in this chapter. Okay students, thank you.